about some solutions for monitoring hydropower plants, and talking more about predictive maintenance, vibration, maybe some pressure, and a couple other technologies that are within our company. To start, I wanted to first talk a little bit about PCB. I'm hoping a lot of you already know about us and have heard of us. We're been around for a long time, since 1967. We're just outside of Buffalo, New York, in a town called Depew. We have offices throughout the world, a lot of direct offices and a lot of distributors, longtime distributors that are really loyal to our company. We have several facilities within the U.S. as well. Our main manufacturing facility is in Depew, and we have facilities in North Carolina, California as well, for some of our products from an acquisition of Devco in 2019. We are very vertically integrated, so we have control of all of our parts to make everything on our products, from the sensor connectors to the cable to the other end, and same with all components related to any sensors we provide. Kind of to help us out, in a lot of our business, we were acquired by Amphenol in 2021, just a couple months ago. Amphenol acquired us from MTS, and we became an Amphenol company just recently. You'll notice the slide at the bottom still says MTS. We haven't updated a lot of our templates yet, so that's coming in the really near future. But we are an Amphenol company as of today. PCB is made a lot of started out kind of in a test market, and over the years has migrated a lot into industrial applications and power generation types of sensors, aerospace and defense, automotive, rail, lots of different markets. I think just about any market we have sensors for. A lot of products that I focus on are related to high temperature specialty sensors for power generation, gas turbines mostly, accelerometers, dynamic pressure sensors, and also anything related to energy or power generation. Now, the Modal Shop, who's helping us host this webinar today, is also an Amphenol company as of today. Formerly at MTS, has always been a sister company to PCB as well. And they were founded in 1990, based in Cincinnati, and they are the world leader for sensor calibration systems and services. We make a lot of different types of calibration systems, and do a lot of in-house sensor calibration, along with lab metrology. They can go out to the field and calibrate and verify sensors, recalibrate sensors, providing reports based on the calibration, and a lot of other programs as well. A big product of the Modal Shop is what we call the Portable Vibration Calibrator, or PVC, and it's used worldwide by end users for field calibration of accelerometers and proximity probes, and just about any type of accelerometer you can think of, or proximity probe. We're able to calibrate or verify, test with this portable field device. It's really a kind of a great device for what it does. It's not expensive, and it's real handy to have around. It's about me. My name's Dave Martin. I've been with PCB over 6 years. I'm going on 6 years, over 5 years. Mechanical engineer. I've focused on the energy and power generation markets for over 25 years. I also got a lot of experience in regular industrial markets as well, pulp and paper, mining, chemicals, just about anything you can think of, upstream drilling. I used to work in the past for SKF condition monitoring and vibrometer. It's kind of my history. I started many years ago with SKF when they had their vibration company starting out, and migrated over to vibrometer, several years after SKF. Focused on hydro power for a lot of years as kind of I want to say a side focus with gas turbines. Hydro's always been really exciting to me, especially lately as it's starting to grow in popularity with all the renewable energy that's coming into the world. I'm a certified Category 3 vibration analyst, not practicing regularly, so I don't know if I could really say I'm still a Category 3, but I have been certified as that. And I've been on the API 670 committee for over 20 years as a member on that for mainly oil and gas applications. Our companies, PCB and the Modal Shop, and our other companies within PCB and Amphenol, we understand power gen. Aside from vibration sensors and system verifications, we've got ground fault detection monitoring. We'll go through a couple systems talking about later on. Got some proximity probe troubleshooting through the portable vibration calibrator. We've got combustion monitoring, dynamics sensors and chains for mounting on gas turbines. We do some industrial hygiene products through one of our companies, Larson Davis, and we have automatic tank gauging and position sensors through our TEMPOSONICS division, which is also an Amphenol company, used to be part of MTS Sensors. We also, kind of the purpose of this webinar is to talk about hydro. So we've got several products that are suitable for slow speed vibration monitoring within hydro. This kind of, going through what I'll talk about, it's just a brief overview. It's kind of a little bit on hydro for some people that might be on that don't know about hydro turbines. We're going to go over that a little bit and how it works. Talk about the duct curve and hydro plants and how their operations work. Go over some of our slow speed and other solutions for monitoring hydros. And then we'll just kind of come to the end and hopefully get some good questions. So, hydropower, as I said earlier, it's kind of I'm going to say as I put in the slide here, renewable power is in. I mean, that's what we hear about a lot, whether it's hydro or solar or wind energy. That's kind of what's really getting into play these days. There's a lot of wind turbines going up all over the world, basically. We used to see them scattered throughout, the U.S. here and there, but now they're everywhere. Just about every state has a lot of wind turbines, along with hydro turbines. So nuclear and coal power are slowly declining in production, and basically, as they decline, more renewable energy is being put into play by a lot of companies, and that's not always due to the companies, but due to maybe some government regulations as them being required. Another newer technology we're seeing out there is battery storage plants that are able to, maybe during low-priced timing during the day of energy, they're able to charge their batteries and then release that energy during higher-priced times of the day. There's also some battery storage plants now going in powered by hydrogen fuel cells as well. So why does PCB care about hydro? Again, renewable energies, the trend. It's what's really being focused on nowadays by a lot of companies, a lot of legacy companies that maybe worked a lot in fossil fuel power gen or themselves migrating over to maybe only renewables, or service companies along with the vendors are migrating over to services and products for renewable energy. Also, older plants, hydro-wise, are running more often and looking for ways to be more reliable, monitor vibration, and help avoid really bad failures. A lot of the small plants in the world, I've seen this for actually a lot of years, even before renewable energy was a focus. I'd go visit a hydro plant. It might have been maybe 10 megawatts, and they said, "Well, we really would like to monitor vibration, but we just can't afford a full-blown vibration monitoring system." And back then, I wish I had a low-cost solution for them. I didn't, depending on where I worked, but with PCB, we've got a lot of solutions for low-cost vibration monitoring within a hydro plant. We've got a lot of in-house expertise to help customers select the right products for the right size of their unit. We've got, again, a lot of different products. And sorry about that. It's on silent, but it rang anyways. And PCB also, we have a program called our total customer satisfaction. So if ever a customer isn't happy with a product or solution we provide, we're going to help them to make it right. If not, we'll take it back. So ultimately, if you buy a product from us in 5 years, it quits working or something, you're not happy with it, we're going to replace it or refund your money. That's just a basic overview of our TCS program. There's a lot more to it than that. So hydro plants, I just wanted to talk a little bit about kind of some of the larger plants. This is the largest hydro plant in the world in China. Three Gorges produces 22.5 gigawatts of power. I visited it once long time ago. It's a massive plant. Pretty cool to go out there and look at it. Some places back when I went, I think safety wasn't as big of a deal as it is now. They used to let you walk just about anywhere within the plant, so it was scary at times to be in certain areas of the plant. In the U.S., the largest hydro monitoring plant is in Washington, called the Grand Coulee. 6.8 gigawatts of generating capacity. I've been to this plant as well. Not nearly as big as the Three Gorges in China, but it's a huge plant. When I was there, it was all the units were running. It was running smooth and quiet. Guys in the plant seemed pretty relaxed because everything was working well. Of course, there's always some problem somewhere within a plant like that, but everybody seemed to be happy that day. These are the largest plants in the U.S. Grand Coulee. I won't go through this whole list, but it kind of goes through like about the 10 largest plants in the U.S. along with their generating capacity. Starting with 6.8 gigawatts down to 1.5 gigawatts in Castaic, California, which I believe is in Central California. I haven't been to that plant, but I believe that's somewhere. No, Northern California is where Castaic is. That's a big plant as well. I think looking over, how real basic hydropower plant works. Water travels through water. Water in a dam flows through a screen to filter out, trees and maybe fish and other debris that might be in a within a dam, in the reservoir above. It flows through a pipe, which is called a penstock, into a turbine, which is, the force of the water makes the turbine spin, which in turn twists the generator and it produces electricity. And, from there, that electricity is sent out to a transformer to increase the voltage and goes out to the power lines, and then the water flows downstream back into a penstock and out into a river. That's real basic, but that's just a good overview. If somebody asked how a hydropower plant worked, that's what I would tell them, just basically, if it's somebody that knew nothing. Different styles of hydro turbines. Francis being the most common type of hydro turbine. It's a good part of the market. I'm not sure the percentage of the market it is, but it is the most common. It's what's called an inward flow reaction turbine. So it combines radial and axial flow. So it's a flow from the penstock where the water comes in, and also the pressure underneath the runner as well. Where a Kaplan style turbine is just an axial flow concept only. So it's just flowing by the water that's going underneath the runner. Pelton, not real common at all. There's a lot of problems with Peltons. I don't know too many of them out there anymore, but it's what's called an impulse reaction. So it just is kind of taking the water wherever it's coming in and twisting the runner. That's why I believe there's so many problems with Peltons, and it wasn't used a lot, is because there's a lot of different pressures of water when it's entering the cavity where the turbine is. There's pressures from everywhere. So I think, in my opinion, that Pelton style couldn't handle all those different water pressures coming into it. The larger turbines, hydro turbines, always have sleeve bearings and proximity probes to monitor vibration, radial vibration. But I've never seen one that doesn't also have accelerometers to look at absolute and casing vibration as well. We don't make proximity probes, but there's some companies that do. But we can test proximity probes if there's failure, but we can provide the accelerometers on a hydro turbine for monitoring all the other points. Again, casing, absolute, gates, different bearings. There's sensors in draft tubes sometimes, looking at draft tube vibration, rotor vibration, stator vibration, blowers, exciters. Everything can vibrate in a larger hydro turbine, and smaller ones as well. Hydro plants, usually again, larger ones have some kind of balance of plant equipment, pumps, fans, motors, and those are all, typically monitored for vibration to some degree, whether it's walk around, data collection, or just maybe permanent mounted types of monitoring. We have sensors. We supply a lot of sensors to walk around data collector companies. So, you probably, if you're in a hydro plant, no matter how they monitor vibration, if they monitor it, you're going to see a PCB product of some kind. Another note on auxiliary equipment, it typically always runs, even when main turbines are not, because it's supplying maybe fans or keeping some sort of flow running within the hydro unit as well. So it's usually always running. I've seen some redundancy as well in some hydro plants with redundant auxiliary equipment in case there's a failure. I want to go over the types of hydro plants just briefly. So there's watersheds. dams where a plant relies on the release from the reservoir to produce power, and that's typically controlled by the plant, that release of the water. Then there's hydro projects, and there's a lot of these as well. They're just relying on the flow of a river. A big river has a lot of flow, so the water flow from the river is turning turbines to generate electricity. Offshore hydro, which I'm still saying is kind of newer. It's probably been around now for a long time, but newer to me. It's using tidal currents and waves beneath the sea to move back and forth and generate power based on the currents and the waves beneath the sea or even above the sea. The oyster wave concept, as it's called, it's moving back and forth depending on the wave. It's like a big wall on bearings, so to speak. It's just moving back and forth, and that movement is able to spin a generator that creates power. It's also we call pump storage facilities, and these pump storage hydro plants are designed with reversible turbines, pumps and motors that they can turn backwards. So, during off-peak hours, they start up the turbine and it's powered. They power it and fill up a reservoir at the top of the dam. So they spin it backwards and fill up the reservoir. Then they turn everything off. And when peak demand comes up and they're needed to run, they're ready. They start to release the water, and it flows back through like a regular hydro plant, and water is released and generates electricity. And the plant makes a lot more money on this than what they spent spinning the turbine manually to fill up the reservoir. So, pump storage plants are pretty cool. I've been to several of them in my past, and it's pretty neat how they work. And I've seen them work, and how they fill up a reservoir. And it's surprising to watch how fast that they can fill up a reservoir. We talking about peak and off peak. So to talk briefly about what's called the duck curve. And what the duck curve is, and you can see kind of in the picture on the lower right, is what it looks like a duck, and that's based on the graph of the imbalance of time between peak demand versus renewable power production. So it's a graph. The duck curve is a graph of power production during the course of a day. So really, most markets would reach their highest demand of power after sunset. Solar power gets turned off because the sun's gone. Typically in the evenings, wind energy diminishes. In most markets, the wind calms down at night, so they can't spin wind turbines anymore. So once all this happens, hydro is turned on. And it's known that once this happens, it's basically a switch, and hydro can come on very quickly to fill the void when the other renewable energies have to get shut down. So once this happens and they reach the lower part of that curve, all the different types of hydro facilities we talked about, run of the river, dams, pump storage are all ready to go at this point, providing they're not under maintenance and something's happening like that. Also, I talked about hydrogen before. I'm going to mention it again. Some of these electrolysis plants for hydrogen production are beginning to be turned on at this point too, for hydrogen power to begin to start. And I mentioned hydrogen a couple times because hydrogen's starting to really be discussed as far as power generation. There's some hydrogen style power plants starting to be developed and built. Some smaller scale units I think are going to be tested first, and then some larger ones. We're probably several years away from that, but that's why I'm just mentioning it in case people haven't heard of it. But I see something probably 3 or 4 times a week about hydrogen and advances made within hydrogen power production. So hydropower and operations, kind of going to talk about large versus small plants, and large plants, kind of like the sizes I showed you earlier at the top 10, even smaller than that. They're manned all the time by people. They're always there, and they're monitored by full-time active vibration monitoring systems. So they can basically shut a large hydro unit off if it needs to be because the vibration level is really high. Whereas small ones are typically manned. I've seen some not or unmanned all the time. Some of them aren't, but most of them are unmanned, and they're remotely started and stopped from a central control station where they're controlling a lot of smaller units at a central control station. So at this point, they use online and remote vibration monitoring to ensure that the plant's running properly and reliably. It's really important on these plants that are unmanned to have some kind of vibration monitoring involved that they can see back at the remote station. So, I've seen smaller plants, and even today they exist, where the plant basically goes offline because of high vibration, but it went offline because it actually crashed. It didn't go offline because it was shut down because of high vibration. It went off because it crashed, which costs a lot of money to repair. And some of these locations, it's very expensive to get equipment where they could do a repair on a hydro unit in these locations. So it's crucial. It's very crucial for all hydro turbines to have vibration monitoring. So, we have budget-friendly vibration monitoring solutions for smaller hydro plants, and also larger hydro plants if necessary that still don't have a good monitoring system for vibration. These are the typical items that are monitored on a hydro unit: the main turbine guide bearing, turbine casing, stator bars, wicket gates. Sometimes are monitored for vibration, not always, but a wicket gate can cavitate, causing a lot of vibration problems and damage if it's not monitored. The head covers and draft tubes, also looking at cavitation with vibration sensors. And the penstock is usually looking at changes in pressure, or also the pressure levels, static pressure level, to make sure that the flow's right and not changing a lot for proper operation of the hydro turbine. Just a little overview slide I wanted to put in, looking at some locations for hydro units, showing where we could supply products to install on a unit. All these products would be lower cost. Some of them would run into some type of data acquisition or protection monitoring system, which we don't supply, but we can supply all of these sensors, pressure accelerometers, velocity sensors, all that type of stuff we're able to supply for a hydro turbine. So main turbine guide bearings are typically have failures because of misalignment, imbalance, kind of the standard things. Could be load zone issues, and that could be related to improper flow to it, which would cause the turbine guide bearings to vibrate excessively. Of course, lubrication is always a problem on any kind of bearing, along with fatigue and wear of the bearing itself. So, we have, this is just a small sampling of the types of sensors we could provide for a main turbine guide bearing. We have a displacement transmitter that's going to look at bearing displacement, triaxial accelerometer that can look at all three horizontal, vertical, and axial vibration areas. We got a very, very cool bearing fault detector sensor, also a transmitter that can look specifically at the frequency that bearing faults typically occur in and provide feedback on that. And also we have a low frequency accelerometer, which is great for, looking at its slower speeds and slower speed related problems on the main turbine guide bearing. Casing vibration. So, I pushed this a lot for really small hydro plants for a long time. And, casing vibration on a small turbine is really, really easy and inexpensive to monitor. And, that can be caused by temperature cycles that change a lot. They start, hot and cold during their run cycles, and they start to wear out, damage internally, structural problems around the actual unit. And so, smaller units, I like to try and push, and I have been successful in getting customers to purchase just vibration switches, real simple, inexpensive vibration products that can turn the turbine off if it starts to vibrate too much. So some of them are really simple, like our mechanical switches, the 685A versions. They're just simple. They can. It's no power required. It has relay outs. There's different versions and different types of relays we provide inside. Different sensitivities and vibration limits can be set in within that. So basically, it shakes and has a relay out that can basically go to this turbine switch, hardware which controlling the turbine to shut it off if needed. Very similar with our electronic switch, but it has an internal accelerometer, or can use an external accelerometer as well. So it does need to be powered, but it's very reliable, more reliable than the mechanical switch. Then we have what we call our 686 C series smart switches, which will they're software configurable. They can be set internally by software for lots of different levels. They have a relay out as well. It's just a 2-pin mill. Again, they would need power. There's an internal relay. It's 500 milliamps. It's small, but you can hook that to an external relay that can handle a lot more, power to shut down the turbine if necessary. And also, we have our, we'll call them seismic sensors, which I've seen these used as well on small units that provide a low frequency output that would detect casing vibration and provide feedback to maybe a transmitter or other monitoring data acquisition system for providing shutdown or alarms to the operators back at a central control station. Stator bar frame vibration. We've seen failures due to unbalanced rotors, insulation problems, looseness. The bars get loose and start causing noise. I've been in plants where I can hear the looseness of stator bars. So we have products. We have one product on the bottom of that list. It's the 649 AL1 rotating machinery protector, and it actually is capable of detecting impacts, which can see that looseness on the rotor. So that's a cool product. I could do a whole presentation on that by itself almost, but it's a cool product. It's used in a lot of different applications like reciprocating compressors or pumps. I've seen it used for looking at cavitation in the past. Also, a low frequency accelerometer and 4 to 20 output vibration transmitters are capable of providing output for stator bar frame vibration problems. Wicket gate vibration, position, cavitation, of course, causes wicket gate vibration along with hydraulic problems, damage from water and corrosion. And the cleanest water and softest water in the world still can damage equipment, especially when it's flowing at a high velocity past this wicket gate all the time. So there's always going to be water damage on a wicket gate. We have our position sensors that can look at the actual position of the wicket gate and look at the misalignment of the position. That's through our sister company, TEMPOSONICS. But we're capable of providing that. And we have a couple sensors that are great to look at wicket gates because they're underwater. Our 607 and 608 series accelerometers can look at the for cavitation and look at imbalance problems and so on underwater to see these issues. Draft tube and head cover vibration, kind of caused by a lot of the same issues we talked about, are also if some debris is able to make it past the screen and going into the turbine. We've got various sensors and transmitters for detecting this and able to provide output based on this. Our velocity output series accelerometers, and we've got a vibration transmitter as well, which these sensors can run into and provide a 4 to 20 milliamp output for feedback into a PLC system. And then cavitation and vortexing issues. So this happens a lot in the penstock at the lower end, near where the water enters into the turbine chamber. Sometimes you'll get vapor bubbles in the fluid flow, and this is caused by possibly the water flow. I'm not an expert in water hydraulics as far as that goes, but I've seen this happen where there's vapor bubbles in the fluid flow, which causes cavitation. Lack of flow can cause, and low pressure both can cause vortexing within this chamber. So, we've got some seismic sensors that can detect this, along with some pressure sensors, real standard, pretty low cost pressure sensors that can look for these types of problems within the penstock. When we get into some of our other products now that we look at, this is kind of our new branding, what it's going to look like, everything except IMI. IMI is a division of PCB, so it's our industrial sensor division within PCB. The other entities where I'm going to be talking about briefly are Amphenol companies, so they're all their own entities within Amphenol, whereas IMI reports right into PCB itself. So for generator and ground fault detection monitoring, we've got our ACCUMETRICS division providing a system looking at ground faults they're caused, possibly when insulation damage around the rotor or stator, starts to where insulation wears out, and it starts to cause the winding to be exposed, causing rotor forging or other issues, and it causes that power within that unit current to be diverted. So this system, one of the systems they have is our AT8000 EFREM monitoring system for looking at potential ground faults. Also, at ACCUMETRICS, we've got an earth fault resistance monitoring system. I'm sorry, this is the same system as I was talking about but it's making. I'm sorry, I was jumping ahead. This is makes continuous measurements of field resistance, location factor, excitation voltages. It has a software package with it for looking at all this type of outputs. It's able to provide 4 to 20s outputs that can be read into a PLC system. It also has digital communication options available for monitoring these types of problems. The outputs of the system provides digital communications, and along with the EFREM software. That is a full-blown analysis software for looking at these types of issues. Also at ACCUMETRICS, this is where I was jumping ahead to, sorry, is our rotor health monitor. Again, one of our many systems that ACCUMETRICS provides. So the AT8300 is looking at rotor health. So it's looking at some ground faults, temperature, current shunts. So it's got some relay outputs that can be used for alarms, maybe an alert and a danger alarm, turn on a light or ring a bell, whatever. Some of these have been implemented in some smaller units to provide feedback to the plant to tell it that there's an issue. 4 to 20 outputs on this system for going into a PLC. And it also, it's mounted on the end of the shaft, typically, is where the system is mounted. So it's easy to mount, providing a hydro turbine has a place to mount this on the end of the shaft for monitoring these issues. Going over to TEMPOSONICS for position monitoring. TEMPOSONICS provides position and also liquid level sensors. They're really big in mobile hydraulics. If you need sensors involved for mobile hydraulics, mobile equipment relies on that. There's a lot of different stroke lengths. So if you're monitoring a WICKET gate, they can go from 25 millimeters to 20 meters. Not that you would ever need to go that far on a WICKET gate, but that's their capability within TEMPOSONICS. They use a magnetostrictive technology sensor. So it's basically a magnet on a shaft that moves depending on the type of sensor it is. So it moves on a shaft, providing an output based on the magnetostrictive position. They have a lot of different outputs. The sensors provide a lot of different types of outputs. It's analog, it's voltage outputs. They've got digital outputs. Just about any type of Industry 4.0 output you could think of is available with the TEMPOSONICS position sensors. This same technology is used in the liquid level sensors as well. So it's just a different type of sensor that can be mounted within liquid. Moving over to the Modal shop, we've got again the portable vibration calibrator for testing and calibrating vibration sensors, standard accelerometers, charge mode accelerometers as necessary, proximity probes. We can check 4 to 20 sensors and transmitters. We can test vibration switches on these, and we can also send an output to a portable vibration data collector to test that device and calibrate it. A lot of people spend a lot of money every year sending away their portable vibration data collector, send it to the OEM or the manufacturer to get it calibrated. I've heard that costing sometimes, $5,000 per data collector to get it calibrated. Well, you can do that with a portable vibration calibrator and get the same calibration done at a much lower cost if you own this. Again, as I said earlier, it's a low cost entry device, so it's not super expensive, budget friendly, so to speak. And this can also be used to do loop checks, vibration systems. So if you've got a vibration monitoring system with alarms set, you can hook this calibrator up to test those alarm levels to make sure they're working where they're supposed to. Where alarm levels, trip levels, all that can be done with this. Our let's say higher end version, the 699 B07, can provide calibration reports. So if any companies require that the sensors have a calibration report on file after calibration, because a lot of companies will just send out their sensors to get calibrated by a company, they'll get a report back and they file that away. Sometimes that's required. So our higher end unit, the 699 B07 or the Modal Shop version 9110D, which is the exact same unit, it's just their model number, can provide calibration reports out of the unit itself. Again, it's portable, can be used in the field. The battery typically can be used in the field all day, charge it up all night, leave it on the charger, and the next day it can be used again for typically a whole day without an issue. And also, as mentioned, all of our portable vibration calibrators are made by the Modal Shop in Cincinnati, which is our sister company. They manufacture them, under their part numbers and also under our IMI part numbers as well. I'm kind of running a little behind. I'm almost done. It's got a couple more slides. I wanted to just talk about this largest hydropower accident in history. This was in Russia several years ago. Basically, a lot of people died in this accident. There was 6 turbines at this SAYANO-SHUSHENKAYA plant in Siberia, Russia. They had increased vibration on their turbine unit 2 main bearing and head cover. From what I understand, I'm not sure. They didn't have any vibration monitoring installed, so they didn't really know it was vibrating as bad as it was till there were guys in the control room that started feeling vibration under their feet and called for a plant evacuation. So it was a big disaster. There's a lot of other pictures. You might want to look it up online under just put in largest hydropower accident in history, and there's some videos of what went on there. And it's pretty sad story. But that is suspected to be caused by vibration. And this is, when that accident happened, I worked for somebody else, but vibration monitoring became, kind of a priority for a lot of plants and operators at that time. So, sometimes these things, they get excited about something, they need something done, and then that gets forgotten. So there's still a lot of those plants that got excited about it where they haven't implemented any vibration monitoring as of yet. So hopefully there's some people on this call that have hydro plants that aren't monitored, or they don't foresee that they might have the money to add vibration monitoring. But hopefully, after this presentation, they'll be able to look at, maybe we can afford some small scale vibration monitoring that PCB has to monitor our hydro unit or units. Just make sure that it's not vibrating too much. So with that said, summarizing, we have many many. I just showed a few above in the application examples, or the the actual parts of the hydroturbine monitoring. We have a lot of low-cost solutions for plants that aren't monitoring. We've got people, application engineers and support, and internal, just regular engineers that have experience in monitoring these type of applications. So, we've got sensors that are also where we have replacements for the OEM sensors. So if you got a sensor that maybe says VoIP on it, chances are we probably manufactured that. So we might have a direct replacement for that at a lower cost. Sometimes OEMs tend to overcharge for their sensors if you buy them direct from them. We've got support available, on-site support as necessary to maybe help troubleshoot sensor problems, which are normally related to cabling problems, but maybe not always. Maybe a sensor has an issue, but we've got support that can help do that out in the field if necessary. We've got, again, fault monitoring systems for generators available through our sister company, ACCUMETRICS. Position sensors available through TEMPOSONICS for monitoring the position of wicket gates or other types of position applications within a hydro. And our hydro, our vibration calibrator, has capability to test any vibration-related sensors on a hydro. And as I mentioned earlier, we don't make proximity probes, but man, we could sure test them all day long with a portable vibration calibrator. Thanks for your time, and appreciate your patience with me. Have a great day.
Thank you. Have a nice day.
Bye, guys.